less than the square root of 2. Either one of those answers is great for me, including number 1. Okay, that's not too bad, is it?
So when you have plus or minus in the answer, you have to graph from minus to plus.
Right, right, because you can see the graph itself, the part that is below 0, is right in this region, which is between the square root of 2 and the negative square root of 2, okay? All right, not bad. Are you ready for number 4?
No, wait.
No.
Oh, yeah.
What about
Wait, yeah, what about B, dude?
Yeah, B. Yeah, you ready for B? Okay, turn the page.
No, wait.
Oh, not yet.
No, hold on.
All right, I will.
Just write it down, dude. I'm trying.
Okay, give me thumbs up when you get it. Thumbs up. Okay, number 4, or B, I'm sorry, 3B. 3B, okay, so we have a 2x plus 7 over an x squared plus 3x minus 18 greater than or equal to 0. So first of all, again, what I'm looking for is all my boundary points, or border points. So for the numerator, 2x plus 7 equals 0. I want to find out what x can equal on the top, or the numerator. If I solve for that, I'll get x is equal to negative 3.5. Minus 7 divided by 2. You guys okay with that? Minus 7 is negative 7 divided by 2. So one of my border points is at negative 3.5. The other border points is where I would have an asymptote, or I'd be dividing by 0. So let's take my x squared plus 3x minus 18. Let's factor that. X plus 6, x minus 3. That'll make a negative 18 when I multiply and a positive 3 when I add them together. So then x cannot equal negative 6 and x cannot equal 3. Cannot equal because if we put them in, we would divide by 0, okay? So all 3 of these values are going to be border points. Again, there's no y. It's not a y x value, so I'm going to graph on a number line. So again, it's going to be on a number line, okay? So put 0 in here. I'm going to have a negative 6. 1, 2, 3, 4, 5, 6. There's my negative 6. 1, 2, 3. There's my 3. Now, here we're going to be a little bit careful. We're going to put an open circle at negative 6, open circle at 3, and at negative 3.5, we're going to put a solid dot. Since we want to know when it is also equal to 0, at negative 3.5 it will equal 0. It cannot equal negative 6 because you'll divide by 0. It cannot equal 3 because you'll divide by 0. So you have to have the open circles on where you would divide by 0. You can have a solid dot of 3.5 because that value would make it equal to 0. Now, again, where do you shade? Well, I think the easiest way, you're going to plug in values, but the easiest way is to graph it. And then just let the trace button, or you can even use a table. Table would work also. But either way, let's put it in the calculus. So parentheses 2x plus 7 divided by x squared plus 3x. Subtract 18. Now let's see what it looks like, okay? Okay, I can pretty much get what I want. I want where it's greater than 0. Looks like it's greater than 0 in this region. Looks like it's greater than 0 in this region. But again, the easiest way to do it is test your regions, okay? So let's test. I've got 1, 2, 3, 4 regions. Let's test negative 7. Let's plug in negative 7. Let's find out what happens at negative 7. So I go negative, so I go trace, negative 7, and I get a negative value. Okay, so it's negative. It's a negative value right in there. Let's try maybe negative 4. And I get a positive value right in there. Let's try 0. I get a negative value in that region. Let's try 4. And I get a positive value here, okay? Now, we're just about there. We just need to do some shading. So what I did is I tested all my regions, and I'm looking for when the darn thing is greater than or equal to 0, right? So where it's positive, it's greater than or equal to 0. So I'm going to shade here. And I'm going to shade all of that. So now, we've got the graph. All we got to do is put it together in interval notation. All right. I'm going to go parentheses, -6, comma, 3.5, bracket. Bracket, because it equals -3.5. Oop, negative. Union, because now we got to also say this. Union. We're going to go 3, comma, all the way to infinity, parentheses. Okay, that's interval notation. Okay, set notation. I'm not going to do set notation on it. Okay. Hi, it's getting easier. It really is. It's getting easier. All right.
Okay, so, which one was it? This one. Orlando, two, next one.
What do I need to do?
Orlando, sending to, his office.
Okay, can I do that later? Okay.
Yes.
Okay. All right, Orlando, you'll have to go, but not yet. Let's get this. Okay. All right, so let's move on to 4. All right. We're going to graph f of x equals 12e to the negative 0.5x. Number 4, yes. All right, now, I do know, before I do anything, I know a couple of things, all right? I know it's y-intercept, so I'm going to put that in right up the bat. This one's not too bad. You guys won't mind this problem. It crosses at 12, so I'll probably go by 2's. I know it crosses at 12, right? If x is 0, this becomes 1. So let's go 2, 4, 6, 8, 10, 12. So 12, and I know for sure it's going to go right through there. So y-intercept has to be 12, okay? It's going to be a decay, but even if you don't know what it looks like, let's take a look at it, right? I mean, don't you love these calculators? So we'll go y equals, clear that out, and we'll go then at 12 e to the negative 0.5x. I'm going to have to change my window slightly because I know at least it starts at 12. So go to my window, and my y min could be as low as -2, but my y max should probably be as high as maybe 20, okay? I know this because I know that it's never going to cross the x-axis. I know it starts at 12, so at least I thought, well, let's go to 20. Okay, let's graph it. There it is. All right, again, 3 things. We need 3 things. We need the correct y-intercept. Okay, we need to make sure we have the right shape, and we need to make sure that it does not cross the x-axis. So this is all I need. I don't need a perfect drawing. I just need something that looks like this, and then it gets closer and closer to your x-axis. Okay. All right, isn't it nice you're going to have one easy one on here? Okay, so we can get at least one problem right, huh? Domain, x equals all real numbers, okay? X can be all real numbers. It is forever over and forever back. You can plug in any value for x, so all real numbers. Range is y has to be greater than 0. It never touches the x-axis, okay? I like that one. Okay, 5. Define the number e. E is equal to this. And you need to put it exactly like this. LIM, limit, as n approaches infinity. Okay, make sure that it's written like this. Lim, n approaches infinity. Okay, this is a calculus term, but that's okay. We can learn a little bit of calculus and pre-calculus. Parentheses, 1 plus 1 over n to the n power. We've seen that as n gets bigger and bigger and bigger and bigger, you get closer and closer to about 2.718 blah 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 blah, which is the number e. Okay. So if I go second e, there it is as a decimal, and as your values get bigger and bigger and bigger, you get closer and closer to that value. Okay. That was easy. Okay, there's another easy question for you, huh? You'd be surprised how many kids miss this, though, because they don't write it down. know how many times I've told you that it's on the test, right? That's enough times. Okay, let's look at 6. These aren't bad either, as long as you put them in the calculator correctly.
Mr. Davies, 1 over 1 plus 1 over n, and then
To the n power. You got it? All right. You guys ready for 6? All right, almost getting there. 6. Okay, so Landon needs to invest $1,000. So we're going to do $1,000 into an account for 8 years. And he finds 3 different banks. So Bank A, we're going to compound. We're going to go 3%. And we're going to compound it annually. All right. So we're going to go A of 8, because we're going to put it in for 8 years, equals 1,000 parentheses 1 plus 0.03 to the 8th power. We don't need to divide by 1 because that would be silly, right? Let's use our calculator. 1,000 parentheses 1 plus 0.03 to the 8th power, right? There it is in my calculator. Enter. So at the end of 8 years, Landon's going to have $1,266.77. Okay?
Wait, what do you mean by you don't have to divide that one?
Right. Well, there's a formula I'm going to use next, and that formula is going to be this P1 plus R over N to the NT. Finn, you might have been absent, right? So the N is the number of times you compound it per year, and if it's annually, that N is 1. Okay, great question. I think you missed that day. So this is the formula I'm going to use next for Bank B, okay? So let's check out Bank B.
so you have to plug the time in A.
Yes.
And then plus the number of dollars and what 1 cent for 1 year,
Right.
plus 0.3 of interest.
Yes.
Okay.
Let's use Bank B. You'll see it again. So Bank B, we're going to go 2.75%. We're going to compound it monthly. So Finn, this time we're going to let N be 12. Does that make sense? So I'm going to go, okay, A of 8, because we're still going to do it for 8 years, right? Equals 1,000. We're going to go 1 plus 0.0275 divided by 12 to the 12 times 8. Now we have to be careful how we put it in our calculator, right? You've got to make sure that 12 times 8 is part of the exponent. If you want to just make that a 96, it's easier if you just change that to a 96. You don't have to worry about it. I'm going to put it in, though, like this, so you can see it. But 1,000 parentheses 1 plus 0.0275 divided by 12 to the power up. Now I got to go parentheses 12 times 8, okay? Because I need the 12 and the 8 to be part of the exponent. All right. So if you get a really huge number or a really weird number, you didn't do it right. I mean, your number should be close. $1,245.76, okay? Even though we compounded it more, Aaron, this goes back to your question. Even though we compounded it more, we made less money, didn't we? Because the interest rate is always the most important piece in investing money, okay? Okay, let's look at Bank C.
Why did you put 1 plus 0 out of 12?
What do you need the 1 plus here, you mean?
Yeah.
This is the one, what the 1 helps you do is get your original $1,000 back. I mean, if you put $1,000 in the bank, the formula gets you the original 1,000 plus the interest. So this is the interest part of the equation, and the 1 is the original investment. So you have to go 1. The formula, here is the formula, Ani, the formula is right here, and I think you have it in your notes, but that's the formula I'm using, okay? P is the
Okay, got it.
principal, okay? Let's go to Bank C. Now Bank C is going to be, if it's continuous, it's going to be a different formula. It's going to be the Pert formula. Bank C. All right, we're going to do 2.5%, but we're going to do it continuously. So we have to use the Pert formula. We're going to use A of T equals P e to the RT. All right, I'm going to use that formula. So we're going to go a of 8 equals 1,000 e to the 0.025 times 8. Okay, and I'll show it on the calculator. I'm going to go 1,000. And now the E button I want to use is this e to the x, which is down here by the ln, right by the 4, second e to the x. And I'll go 0.025 times 8. And again, my answer should be close to the others. If you're off, if you get an answer that's way off, then you know, probably did it wrong. Try it again, okay? So I get an answer of $1,221.40. And again, Aaron, less money, huh? Even though we compounded every moment, every second, we made less money because that interest rate really carries the day, doesn't it? Okay, everybody can do that, right? Everybody's good to do that tomorrow? All right, last one. Last one. Almost done. 7. So, the population of fish in a local pond grew logistically modeled by the population, okay? So what's going to happen, it makes sense that, a pond only has so much size, and at first when you introduce fish and you put them in there, they're going to grow like crazy. Lots of nutrients, lots of food. They're going to grow, the population is going to grow, and then all of a sudden they're going to start getting a little bit crowded, right? And then there's not going to be enough food to take care of the entire population, so it's going to level off, right? Unless we build a bigger pond, you're going to have a contained population. So let's take a look, okay? So we're going to have this P of T, population over time. P of T, population over time is D over 1 plus K e to the negative CT. All right, let's see what we've got. So they tell us D is 800. We have K as 11. C is a 0.2, and that's kind of like the growth factor. That's the rate at which they grow. And T is measured in years. So let's go and put this in. We're going to have P of T equals 800 divided by 1 plus my 11 e to the negative 0.2 t. Right, there's my equation. Now, if I can put it in my calculator and see it, that's going to help. Now, I may have to have a pretty big window. I see 800 here, so let's go y equals clear 800 divided by parentheses. You're going to need a parentheses here. Okay, parentheses 1 plus 11 e to the x negative 0.2x parentheses. Now I got to have parentheses there and there, parentheses and then another parentheses. Okay, so you got to have the double parentheses in the back. You can kind of see it from there. Okay, window. Well, I don't need to worry about negative 10. I got negative x, but I don't need negative 10. I can just go 0. Oh, maybe I'll make it negative 1 so I can see a tiny little bit of it. How many years? I could go, this is 10 years. Let's just go 30 years. I don't know how long it's going to take. Max. Well, I got 800 here. Let's just try 800 here, and if we need to change what we will. We'll go 800, graph it. Hey, that wasn't too bad, huh? That looks pretty good. So, A. We're ready to get some answers. T equals 0. Originally, that's at time equals 0, right? So I could plug 0 into my equation, or I can just go trace. I like my trace button. Trace 0, and I get about 66 2/3. So we'll round that up to 67 fish. Okay. All right. I went trace 0. I got an answer about 66.6. I rounded up to 67 fish, or I could have rounded it down to 66 because somebody could say there can't be a 0.2/3 of a fish. I'm okay with that. Population after 10 years. So let's go T equals 10. T equals 20, and T equals 30. So again, easiest way to do it is just plug them in. So I'm going to go to my trace button. I'm going to go 10. And I get about 321 fish. I'm going to go 20. about 666 fish. And then I'll go 30, and I get about 778 point fish, whatever, I don't want point fish, or 779 fish, okay? Graph P of T. Now I've got plenty of information to graph it, so I'm going to try and put my graph down here. We're almost done. Oh, let's see. Let's go 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. There's 20. 2, 4, 6, 8, 10. There's 30. And 2, 4, 6, 8, 10. There's 40 even. 800. So maybe I'll go up to 1,000. Let's see. That's 1, 2, 3, 4. We'll go 500. 1, 2, 3, 4. There's 1,000. So we know that 800 is, let's see, that's 750, so 800 is right about there. And let's see, we'll go T0, we'll go 67 fish, which, you know, you can barely see, so put a dot down there for 67 fish. 10 fish was 320, it's about there. 20 fish was about 666 fish, maybe about, I'm estimating about there. 30 is about 778, almost 800, and so it should look like this. Now it levels off at 800, so you could put a horizontal asymptote at 800, okay? Yeah.
How did you get 67? Did you just put the graph in the calculator and go to the table and go to 0?
Yes, I didn't do it that way, but
Oh,
yes,
you went to the graph and did
I just went trace, I just went 0, right? There you go. But the table will give it to you also, right? Table, I mean, if you guys do the second table, you get the values there, right? There's my 0 treat, and then I can get my others from that. But I like the trace button. That's my preferred way to do it, okay? Now, what will the population eventually level off to? What do you think? 800, right? So level off to 800 fish, okay? Okay, that's it. I think the hardest question is definitely number 2, right? And we're going to stop recording.